going to be looking at solving quadratics today by factoring. So we're going to look at how we can use some of that factoring stuff we've done in the last couple of videos in order to actually solve it out. Before we do that, let's just kind of go back and review a little bit some of the stuff we did with the graphing. Okay, recall anytime you are graphing, you got a quadratic, we know we got this a value here of 1, a b value of -2, and a c value of -3. Your y-intercept is always whatever that last one is, the c1. So our y-intercept or our graph should cross through at -3 there. The vertex and the axis of symmetry both use this little equation of x equals opposite of b over 2a. So now plug in those values and see what you get. On this problem, that would be opposite of -2 on top, 2 times 1 on bottom. That's +2 over 2, which equals 1. So we know on here that our axis of symmetry is at 1, which means on the graph it should be symmetrical about this green line right here. And also our vertex is going to be on that axis of symmetry at 1 something. In order to find that other part of it, you want to plug 1 in and see what you get. What do you get when you put 1 into that function up there? Well, we could quickly find that out. We do 1 squared minus 2 times 1 minus 3. That's 1 minus 2 minus 3, which would come out to be -4. And so the location is at 1, -4. So we know at 1, -4 right here, there's a point. We could also get another symmetrical point here. Our -3 one is 1 space away, so there would be another symmetrical point there. The next thing they want us to find is the zeros. That's where it crosses our x-axis right here. So where, if we keep extending this up, is it going to cross through? Okay, we know these are going to connect here, and we're going to get that U shape, but where exactly does it cross through? One way of doing that would be to continue our table here and see what we get. So if we were to make a little table with our x and y values, with the point 1, -4 as our vertex point, okay, we know there's a symmetrical point at 0, -3, and 2, -3. What do we get if we put -1 or 3 in for that? So similar to how we did before, what if we just go ahead now and change and put in 3 in place of this? What is this going to come out to equal then? Okay, well, let's see. We put 3 in. 3 squared is 9. 3 times 2 is 6. 9 minus 6 is 3. Minus another 3 would be 0. So it looks like we get 0. Our symmetrical point would also be at 0, meaning there's points here and another symmetrical point there. And if we continue, we see our parabola and we get that U shape. Where is our zeros? Where did it cross the x-axis? Well, we can see very clearly now at those 2 points. At -1 and 3, that's where we had our zeros. We get 0 for our y value. Well, what we want to be able to do today is do the same problem, but rather than maybe having to graph it out, could we find those zeros another way? Could we get the zeros from the equation here is what we're going to be looking at. And you can do that with some factoring. So what we're going to be able to do is take that same problem and factor it. What would we get if we factored that out? Okay, well, we know from factoring the last couple days, we want to figure out what's going to multiply to -3, and the same 2 numbers add to -2. Well, the numbers that would do that here would be x minus 3 and x plus 1. 1 times -3 is -3. If we add them, we get -2. Well, how do we get our solutions from that now? Okay, because we do have that this is equal to 0. So now this is equal to 0. And to finish solving this, what we're going to use is a property called the zero product property. So the zero product property, what it says is if you have 2 things equal to 0, then anytime you're multiplying and the answer is 0, that means either that has to be 0 or that has to be 0, because the only way to multiply two things and get an answer of 0 is for those things to actually be 0. So if we know that that's true, okay, then what we can say is that either x plus 5 equals 0, that's the first thing over here. This has to equal 0, or the second thing has to equal 0. And then those are just equations you can solve. Minus 5 from both sides, and you get the answer of x equals negative 5. On the next one, you would plus 7, and you get an answer of x equals 7. Those would be the solutions. That would actually be where your graph crosses x-axis. Okay, so kind of the steps involved there, what we did was set the equation equal to 0, factor completely, set each factor to 0, and then solve each equation. So let's finish that one. We were just looking at back at our graph here. We factored it, it's equal to 0. Now we want to set each of these two equal to 0. X minus 3 equals 0, x plus 1 equals 0, solve them, and we get our answer, 3 and negative 1. Were those the same zeros we had here? Yep, we got same two numbers, negative 3 and 1. Negative 1 and 3 were the two places that our graph crossed the x-axis. So it's the same, you get the same things just by factoring. It's a little faster than having to graph it all out. So let's see if we can do some more of those. Okay, first one, number 1 there. We want to solve it. So first thing we need to do is set it equal to 0. Right now, we do not have 0 on either side. So then your job is to get it equal to 0. When you're doing this, you always want to try to keep your x squared term positive. Since it's positive already, let's move everything to the left side. So let's minus this 6x over to the other side. Now that that cancels out, that side's equal to 0, and we got x squared minus 6x. So now we got step 1 done. Next is to factor. This one has a greatest common factor, a GCF, greatest common factor of x. What do we get if we factor that out? Kind of like the opposite of distributing. We'd have an x left and a minus 6. Okay, so now we got the factoring. Now we want to set each factor equal to 0. So put the x equal to 0, put the x minus 6 equal to 0. Last thing, solve it. Well, there's no solving to be done there. One answer is 0. On this one, add 6 to both sides, and another answer is 6. If we were to graph this one out, you would see that the parabola crosses through at both 0 and 6, and it's probably some parabola that looks like that. Okay, let's try another one. Number 2, get to solve this one. Okay, check our x squared here. Now, it'd be easiest just to minus this over, but then it's negative. We don't want it negative when we're factoring. That's harder to do. So instead of moving everything to the right, let's move these other terms over to the left. Let's subtract both of those. So now our equation would be x squared minus 5x minus 14. And once this stuff cancels out, it's going to be equal to 0. So we got that step done. Okay, now factor it. What's going to multiply to negative 14 and add to 5? The two numbers looks like it'd be something with 7 and 2. And we want the 7 negative and the 2 positive here, so that adds a negative 5. So we factored it. Now set each factor to 0. Put x minus 7 equals 0, x plus 2 equal to 0. So we did that one. Last, solve them. If we add 7 here, the one answer is 7. If we minus 2 on the other one, the other answer is negative 2. Now we got our answers. That would be the solution. Again, if you were to graph this one, you would see that at 5 and negative 2, those would be the two locations that this parabola crosses through the x-axis. All right, why don't you pause the video and see if you can answer both 3 and 4 here and see what you get. All right, let's check it out. Let's see how you did. On this one, the two numbers that are going to multiply to 64 and add to negative 16 would actually be the same number, negative 8 and negative 8. If you put both of those equal to 0 now and solve, you get a solution of 8 and another solution of 8, which means this one only has one answer. It is that x equals 8. If you were to graph this one out and find where 8 is, that's the only spot where it touches the x-axis. So that's one of those parabolas that just hits one time right there. All right, let's see how you did on the other one. This one's not equal to 0 yet. You got to make sure it's equal to 0. So first step on this one would have been to minus 9x. Okay, this is one of those. You got to look to factor greatest common factor out. Looks like a 3 goes into both of these, and we could factor out an x. So what's left? Kind of like the opposite of distributing. 1x with the first thing, 3 with the second one. Now set both of those equal to 0 and solve. Okay, first one we'd have to divide by 3. Well, 0 divided by 3 is still 0. So one answer would be 0. And the other one looks like you get a plus 3. So the answer there would be, those would be the two locations that one crosses through the x-axis. All right, let's try a few more, maybe a little bit different, a little bit harder than the ones we've looked at so far. These are on the back now of your note sheet. So here, again, try to keep this one positive. So the first thing we'd want to do here, minus 1 and add x to the other side. Cancel these out. And I'm going to put them in descending order here. So we got 6x squared plus x minus 1 equals 0. Okay, these are one of those ones a little bit harder that we did on the last video. Okay, you got negative 1 here. So we know the two things that are going to multiply to negative 1 must be plus 1 minus 1. The harder thing here is you got that 6 there. Okay, so there's one of two options. It could be 6 and 1, or it could be 3 and 2. We got to kind of check and see which one's going to work here. So let's try 6 and 1 and see if that works. So to check it, times these together. That's negative 6x. That's 1x. If we add those together, that's negative 5. Is that what we see here? No, it needs to add up to 1. So since that didn't work, let's try the other one. Let's see what happens if we put 3 and 2 in there. Now if we times these together, you got 2x, negative 3x. Those add up to negative x. We got a positive x, so we're really close. If we get something like that, remember you just switch the signs around and it should work now. So let's switch these. Let's make that one negative, that one positive. And now that one should work out. So now we set both of these two terms equal to 0 here and solve them just like we were doing before. Now this one has a few extra steps in it because we can't just quite divide yet. We're going to have to add or subtract those numbers over first, then divide, and you get it. Now if we take and divide by 3 here, it's going to be a decimal. Rather than having it be a decimal, we can just leave it as a fraction here of 1/3. So that would be one answer. If we do a similar thing on this other one by subtracting 1 and dividing by 2, looks like the other answer would be negative 1/2. So those would be the two places that one would be crossing through. All right, another one here. A little bit different one. This is one of those difference of squares ones. If you notice, like on our last ones, we've always had 3 terms here. We've had an a number, a b number, and a c number. Here we do, it would be a of 1 because there's a 1 here. Our c would be negative 25. We don't have that middle term here. That means it's 0. So that means this one's kind of like another way we could write this one would be x squared plus 0x minus 25. Well, what's going to multiply to negative 25 and add to 0? It'd be the same number, 5 and 5, except one's positive, one's negative. That's one of those difference of squares ones that we had done on a previous video. And so on this one, again, same thing, put them both equal 0, solve. And the two answers we'd get here, by subtracting 5, we'd get -5. And by adding 5, we get +5. So those would be the two places this one crosses through the x-axis. Okay, number 7. This one now wants us to write a quadratic equation in standard form that has these two solutions or two roots. Okay, so this one's kind of almost working backwards from the problems that we've just done previously. For example, on the last one, they're saying the two answers are this and this. Well, look at what we did just previous to that. The thing we just did previously was we had that equal to 0 and solved it. So we want to do the same thing here and think about, okay, if these are the two solutions, what came just before this? So if we have x equaling -5 and x equaling 7, we want these equations equal to 0. So almost work backwards here. We want to add the 5 back to the other side, minus the 7 back up to from the other side, and see what these are equal to 0. This would be x plus 5. This one would be x minus 7. Now we want to take these two things to get the equation and times them together. What's x plus 5 times x minus 7? And that'll give us our equation for this problem. So now we want to work backwards again. These are already factored to multiplying back together. That's that FOIL process that you've learned before. Multiply first, outside, inside, last. So the first one's x times x, that's x squared. The outside ones, that's -7x. The inside ones here is 5x. And the outside ones, I'm sorry, the last ones are -35. Now we want to add any like terms together. These middle ones are like terms, and so the quadratic equation that came from this is x squared minus 2x minus 35. That would be the quadratic equation in standard form that would have these two roots. Let's try another one of those. This one a little bit different now. Now you got a fraction involved. Same process though. The two values for x are -1/3 and 4. We want to get those equations to equal 0. Well, this one on the right is pretty similar to the last one we just did. All you got to do is subtract 4, and you get x minus 4. Okay, so one of the two things we're going to want to multiply here is x minus 4. The other one's not so easy. Now, we could just do +1/3, and we would get x plus 1/3, but that's going to be really messy to have to multiply through by some kind of fraction. So rather than doing that, we can get it as something without a fraction by doing some multiplying first. We got some this is being divided by 3. So what's the opposite of dividing by 3? Multiply both sides by 3. So if we times both sides by 3, now you got 3x equals, what's left here is -1. And now if we add 1, now this is no longer a fraction. This is going to be much easier to deal with. Let's times these two together. So now go through and multiply this using that FOIL thing again. First, outside, 3 times -4 is going to be -12x. Inside, that's 1x. And the last ones, 1 times -4 is -4. Adding our two like terms together here, this would be the quadratic equation that would have these as its two zeros or solutions on that one. Okay, one more. On this one, they want you to do the same thing, except they want you to kind of pick the roots out on this one. So if you look at the graph here, looks like this one has a root here and a root here, a 0 there and a 0 there. That one's at x equals 0. This one is at x equals 4. So now do the same thing we've just been doing, and you should be able to get the formula for that one. This one, there's no really solving to do. That's just going to be x. Here, we'd want to Subtract 4 from each side, get that equal to 0. This one's going to be x plus 4. So now take our two things, x and x plus 4, and multiplying together to get your equation. So you got x times x plus 4. This one, we don't need to FOIL, you just have to distribute. The equation for this one would be x squared plus 4x. That would be the quadratic formula for that parabola. Okay, a couple geometry ones to end here. You could also use some geometry when doing some of these problems. It says the height of a parallelogram is 4 millimeters more than its base. If the area is 221 millimeters squared, find its base and height. Well, think back, or you've looked at parallelograms back in geometry. We know that the area is the length of the base times the perpendicular height. Okay, so what we know here is area is going to be 221. We can put that in for A. Okay, the base and height we don't necessarily know. But what they tell us is the height is 4 more than the base. So if we're calling the base B here, that means the height is the base length plus 4. So what we can do here is, instead of having the base times height, we can substitute in now for the base and height. Base we know is still going to be B, but the height we can substitute in base plus 4. Now if we solve this out, we should be able to find what the base and height is. Start by distributing here. Okay, now this is just like one of the problems we did at the beginning. You can't solve this by doing any dividing or subtracting or anything like that, because you got b squared here and b, which are not like terms. So if you got not like terms, that means get it equal to 0 and then use some factoring or other method to solve. So we want all this stuff to the same side. Right now our b squared term is positive. We want to keep it that way. So let's move everything to the right side here. Let's minus 221. So now this side is going to be equal to 0. That's what we want. We got b squared plus 4b minus 221. So now our next goal is to solve that. We can factor. So we got b times b will give us the b squared. Now we got to think, what's going to multiply to equal that, and the same two numbers add to equal 4. 221 is kind of a tougher number to deal with. It's not one we are using as often. So let's try, instead of figuring out what multiplies to 221, let's try dividing by 221, because dividing is the opposite of multiplying. So let's see if we can figure out some numbers that might go in there. 2 definitely doesn't, because it's an even number, is not going to go into an odd number. Let's try dividing it by 3. No. Let's try 5's not going to work. Let's try 7. No. Let's try 9 won't work if 3 didn't go in there. Let's try 11. Nope. Let's try 13. 13 and 17. Can we get 4 from 13 and 17? Absolutely. So this one is going to be, we get 17 and 13. We want the 17 to be positive and the 13 to be negative if this is a positive 4b. And so now do what we did before. Put both of these equal to 0 and solve, and you'll get the answer. And so here, if we minus 17, we get an answer of negative 17. And if we add 13, we get another answer of 13. Which of them is the base? 13 is. Why not negative 17? We can't have a negative length. So our base length is 13, and I think it was in millimeters. So that was one answer. And then if we take and add 13 plus 4, that means our height is going to, sorry, not 14, 13 plus 4, we get 17 millimeters for the height. So that would be the length of the base and height in this one. All right, let's try one more of these ones. Height of a triangle is 3 millimeters less than the base. If the total area is 44, find the base and height. Okay, think back, triangles. This is one you should know for ACT. Area of a triangle is half the base times the height. Okay, so again, we know 44 is something we can plug in here. Okay, we got our base length on the bottom, got our perpendicular heights right here. They tell us that the height is 3 less than the base. That means the height would be the same as the base minus 3. Okay, so if we substitute these in for the height here, we should be able to get it. So making our substitutions, we got 44 equals 1/2 the base, and instead of height, we're going to write base minus 3. Okay, now we want to solve that. Okay, to solve it, one thing I see is that we have this divided by 2. Well, what's the opposite of dividing by 2? Timesing by 2. Let's times both sides by 2 here. So then we don't have to deal with a fraction. Now we got 88 equals b times b minus 3. Okay, let's distribute both. B squared minus 3b equals 88. We want to get this equal to 0. This is a quadratic. Since b squared is positive, let's minus the 88. Now we got it equal to 0 like we want. Now we want to factor. We got b and b. What's going to multiply to 88 and add to 3? This one, if you think about 88, the easiest numbers that we know that go into 88 are 11 and 8. Can we get 3 from 11 and 8? Yep. We know we can get 3 from 11 and 8. Here we want the 11 negative, the 8 positive, because we got a negative 3 there. Now put them both equal to 0 and see what you get. So doing that, we get a base of 11 or a base of negative 8. We don't want to use the negative one. We can't have a negative length. So it looks like the base length here is going to be 11 meters. And then if we substitute that back in up here for the height, if we got 11 minus 3, that means our height's going to be 8. And that would be in meters as well. All right, try some of them out now on the practice.